This is amazing. This is like the most open source at a crazy bleeding edge. To me, it marked a very clear evolution in the internet, and I just wanted to be a part of it. The superpower of how to deliver great engineering, it was really in the architecture. In the world of startups, there's so many vectors, but from the perspective of engineering, you can be fast and productive. Always be shipping. This is kind of what we're doing. I'm not joking when I say I'm really passionate about open source. I have tons and tons and tons of open source libraries, actually.
Hi, I'm Brett Gibson, and welcome to HighBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups. In today's episode, we're sitting down with Peter Kieltyka, co-founder and CEO of Horizon Blockchain Games. Horizon is the maker of Sequence, an infrastructure stack for Web3 game developers that includes the simple-to-use Sequence Web3 wallet. The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them. Hey Peter, thanks a lot for joining me today.
Hey Brett, nice to see you, man.
Let's start off with you telling everybody what Horizon does.
We started Horizon 6 years ago, and it is a Web3 infrastructure company focused on helping developers build Web3 applications and games and delivering an amazing user experience for the end users who are consuming the content.
I know we've talked a lot over the years about all the interesting problems in and around crypto and around, making things easy, which is a big focus of the firm, both for developers and users. What are the hard parts in delivering this crypto gaming platform?
Man, so many. Yeah. If you've ever used, a dApp or a blockchain application or a wallet, the technology is all really interesting, really exciting, but it's also very brand new. It's on the basis of peer-to-peer systems and decentralization. So there's all these extra layers and around cryptography and security. In the community, when you're trying to make something, you always want to maintain the integrity of the decentralization and the network so people can have their non-custodial or self-custodial nature of these things. But yet you want it to be accessible to everyone, right? You don't want this to just be like, the people with the know-how or this like special secrets that you want anyone in the world to be able to navigate this and enjoy, just like we navigate the web. So there's a plethora of issues. And the reason for that is because the blockchains, as they are new sets of protocols, they're very kind of close to the metal, very raw. And a lot of the first initial clients, like call it a wallet. Usually people think about wallets. Those are the things that interface with the blockchain at the first level. In something like MetaMask, for example, incredibly popular, great product, but it's very close to the metal. It's like a single private key and you're signing transactions with that key. You're constructing a payload. It's helping you pick a gas. You got to pick, what gas do you want? Oh man, I don't know. What gas do I want? Like you pick the gas, you fire the transaction to the node and you hope that like you're waiting with the confirmation. Like, did it work? Did it work? Did I screw it up? And then what if you don't even have the gas, right? So there's a lot of problems with like, again, how do you handle the private key, which is a difficult thing because it's easy to mishandle. Are you signing the right kind of information? What is the gas price? And where do I get my underlying cryptocurrency that you need to pay for the gas, like on Ethereum where you need ETH or Bitcoin, you need BTC and so forth. So, and that's just the beginnings of some of the problems. We wanted to make a video game, Skyweaver. And of course, a video game is it's not like a financial product. It's a game. Anyone should be able to have fun with it. We, right from the onset, were like, we have to make this stuff accessible so anyone can come into it. And as we were hitting all these points, we made a big list of all these things, and then we solved it. And so Sequence is kind of this middleware infrastructure layer. It's a set of services that build on top of a blockchain, kind of wraps itself around the chain and solves, a lot of problems, which that's the starting point.
Yeah, it makes a lot of sense. The aspects about blockchains that make them secure and the reason that they're valuable in the first place are always the thing that make delivering the kind of user experience that you're used to delivering hard. And so you come to this thinking, well, I'm gonna make this middleware which bridges the gap. Being someone who built a bunch of different products and someone who also was a believer in blockchains, how did you come to decide that this is what I want to work on?
I just love software development. When I was like 15 or whatever, I loved open source. I was I mean, I just used it, and I would look at the people who wrote open source software like heroes. They're like, these are just geniuses. Like, how are they doing all this stuff? Like, how do they know how to do this? And it was always a life goal of mine to contribute a meaningful piece of open source software, that other developers would get to use. And I was lucky to achieve that. I wrote a program called Chi, which is like a library for making microservices in the Go community. Has 16,000 stars and all this stuff, and I'm really proud of it, and I love it. And there's been tons of open source stuff, right? And Chi came before Horizon. But when I had come upon blockchain technology, the other thing is, like, I guess I spent a lot of my years developing infrastructure software, like backend systems. Like, I'm kind of mostly a backend developer, like done all up and down the stack and sideways, but still my forte would be backend development. And so I've always also appreciated distributed systems, just peer-to-peer networks. I thought they were really fascinating because they're like these like self-resilient networks. You know what I mean? It's like, they're like organic, and they're like all of the same nature, and they offer high availability and high scalability, like all the properties we want. And it occurs just through the architecture at which it's based on how the patterns are formulated that you achieve these properties of all these like awesome properties to make web scale stuff, right? And it's like self-resilient. So the combination of like open source, distributed systems, and cryptography and economics, I was just like, for me, I was like, this is amazing. Like, this is like the most open source, like at a crazy bleeding edge with all the coolest stuff in it. And to me, it marked a very clear evolution in the internet. And I just wanted to be a part of it. It was just freaking super fun. So I was like, I knew I was doing something there, and that's it. Yeah.
Okay, let's talk about a problem, in the engineering space you solved. And I think that in our discussions, there's probably a lot for you to pick from. We wanted to zoom in on something that you found and how APIs are created for modern client-server web applications. What is the context and history of this space?
Yeah, I've been developing tons and tons of software, love making software, and obviously like internet software, web software, right? Applications, and obviously web software applications need backends, right? And usually backends, when it relates to web applications, it always means like APIs. And so I've been doing all sorts of stuff, like before mobile existed, right? Mobile, smart, they didn't exist, and I was still building like web applications, you know what I mean? And then when mobile came out, APIs were even more on the rise, right? Because then you had like a web application plus a mobile device, and that's how these client server kind of paradigm really also kind of increased, because that's how you're able to kind of create these connected systems. And if you think about the evolution of a web application, back in the day, you had a simple website, really cool. You could actually make CSS and make it cool. And then you had to go and you have a web server, awesome. And then you discover like PHP or something. And now you can do server side, like, dynamic content generation. Like, oh my God, I just like meet a random page on a request. Like, that's pretty cool. And then you evolve to that. You got like something like Ruby on Rails or Django, which gives you even like more capabilities, more productivity, all this amazing stuff. And then of course you evolve to things like single page applications.
There's this big jump between delivering a bunch of HTML to the client and having one big app that has to talk to the server as it goes.
Exactly. Crazy jump, right? Crazy jump in terms of different paradigms and development processes and libraries and the whole stack, and everything is so different. And it's interesting, over the last like 15 years, everybody's been trying to push as much they can out of like web applications. They want them to be like desktop applications. I mean, the cloud pushed that, everything we have now. And of course we're here now, right? But like, what happened over the last 15 years? And for me, as a developer on this journey, I had to, of course, I was passionate to be on the bleeding edge. I was right there. I was on the backbone.js, I was on the Ember.js, I was on the Angular.js. I've used them all, and then of course React.js, I saw all of them. Remember when React just came out, and we're like, oh my God, now I got to rewrite our application again. You know what I mean? Like, what the hell? Yeah. But in all these things, one of the things that kept being just a lot of work, again, the writing APIs and writing systems. And I do recall when I first came upon, and there's a lot of reasons why you'd have APIs, but in the context of a web application to be powering like these single page apps, when we started doing it, a lot of the time when we were writing our first APIs, we were doing it, again, like over many decades, but writing like RESTful APIs. Everybody was writing REST APIs, and REST was like the most popular thing. Everyone was talking about REST because it's the right way to have the conventions so that you can have the right structure, and your application knows what to do, and you're posting and you're essentially doing all your CRUD, create, read, update, delete stuff like we were all taught.
All the Rails fake non-existent HTTP methods that they wish were there that you put in the header and stuff. Yeah, and it worked amazing. Like, it was so cool, so productive. People could like if you remember DHH's build a blog in 15 minutes. That was like that was legendary. That
and I think, I don't know what year that was, but it was like the best go-to-market strategy I've ever seen for open source project. And it was incredible. And then when did you ever do any Rails?
I wrote Rails most of the code I wrote was Rails, actually. It's funny because I used to joke that I'd written Rails for like 10 years, but the last time I chose it was 2006. People knew that I wrote Rails fast, so I kept inheriting Rails projects over the years.
Yeah, because I know like you're obviously doing your initialized thing now, but I know you're a seasoned engineer and developer and you have all this background as well. But Rails is still popular. Like, I'm not using it; I haven't used it in a long time. But Shopify is very successful with it to this day, and it's of course an incredibly competent system. I'm not familiar with the latest of it, but I do remember back then like being like so productive with it. And then I was like trying to use like Emperor.js or Backbone.js, and I'm like, oh my God, I'm so slow. Like I can't do anything. Essentially the reason was, you had to kind of build your application twice, right? So you had to like build the back end, write all your data structures, your models, create all your endpoints in RESTful way, figure out the different conventions at which you would construct the things in the data structures. And it felt very loose a little bit. And then you have your client application, and you'd have to re-implement a full client library that was able to talk to it and then decode it and then have the right data structures. And and then imagine you then had like another language. Like what if your web app was in like JavaScript, which it always is, or TypeScript, same thing ish. And then you got to go make like maybe your server's talking to the API. And then what if you have a mobile app also talking to your API? It's like, what, you're going to write that client library like 3 times?
Yeah. Yeah, as soon as you had object management and it wasn't just get a response and render something, the mismatch between the two became the thing.
Yeah, it's huge, so much work.
Remember a lot of writing client libraries that had different names for all the fields and translation things. And I definitely spent some time in that world.
Yeah, exactly. It's a huge amount of work. And like when you make an app, it's one thing to make like a few endpoints here and there, but like I built REST APIs with over 100 endpoints. Maybe 200. I can't, maybe more. I can't, like over 100 easy. And we actually made it, it actually was maintainable. It's a very well engineered piece of software. Yeah. But I remember how much work it was every single time. We had to coordinate with like, our front-end developer or back-end developer. We had to meet as a team, like, what's the right convention we want to use for this, and passing query parameter. And it's like way too much work. And that's when I was thinking to myself that like, there has to be kind of a better way. And that's kind of when I think I came upon GRPC for the first time. And it was a project from Google, and it took like this protobuf, and the idea was, they had this like schema, this profile. You define and protobuf is really like a binary serialization format to have like, super compact and fast decoding and encoding of data structures in binary. And people would use it for all sorts of stuff. It's still very popular. And then gRPC was an extension of protobuf that added the ability to have essentially like HTTP handlers and like using those data structures as request and response payloads, as well-defined request and response payloads. And I thought, I was like, wow, that's a really cool thing. And I heard about it, I guess, from the Go community. And then I was like, I got to try it. So I tried it out. There was a lot of things that were really difficult to work with. But I really loved it because the idea was you define your request and response types in a schema, and then you could code generate your clients. Like the full client library would be code generated. And that's that's amazing, because in fact, the client libraries are quite mechanical. They follow a set of conventions, and they should. And so you could technically kind of automate the creation of the code itself just off that file. And it worked pretty well. And so it was popular within like, gRPC was intended for service to service communication. So like, microservice to service communication, which again, very popular still to this day. Uber uses it, Lyft uses it, like everybody uses it. But where it didn't work great was kind of server to browser, because you'd have to be decoding protobuf structures. And really like the native structure that we use on the browser is JSON. So it didn't really fit. And the other thing was, if you're trying to represent certain data structures in protobuf, there are some limitations. It's not as dynamic as JSON. There are certain like things you just can't represent. And also, if you ever wanted to change anything or do something, or even the tooling, it was just like a disaster.
Well, JavaScript types are a little funky. So translating for something that's not already JSON aware, it probably has its warts.
Yeah, it's binary format, versus JSON is like you can do anything you want. It didn't map well. And then, then you have to decode it as well. And it was difficult to modify the client libraries. And they weren't you couldn't use it with curl, for example. So there's a lot of things that weren't great. And that's when, once I wrote my first prototype, that's essentially, so what I did was, and I sat on that for a little while. And then one day at Horizon, while we have probably 10 different API services that exist within our middleware stack, and there's quite a lot. There's a lot of code, a lot of things to maintain. At the time, I mean, that's over the course of the years, but now, when at some point when we were developing these APIs, I was convinced that this paradigm made sense. The idea of a schema-driven approach to writing backend infrastructure services that would fully code generate your client libraries in the browser.
Wait, so maybe let's set the stage. So you'd had this problem for years. You'd been thinking about like a more elegant solution, but then you had this real need at Horizon, when you were just forming and starting to set up client server services.
Exactly. So it's like something I've been like struggling and was bothered with for 15 years, and then I eventually like proved out the thing, but wasn't satisfied with the end result, and I was hitting a bunch of edges with, like, again, gRPC, very popular, very capable, all that stuff, but it wasn't the right fit for what I wanted from like client server speaking to a web browser. I wanted something simpler and lighter, and so I've made this thing called Chi, which lets you write microservices, and it's like an HTTP router, lets you define your routes, and in a really modular way. You can use it to write REST APIs. And in fact, that's why I wrote it in the first place. After some time, I had discovered this paradigm, or this like pattern that I thought was a lot more powerful via code generation. I then spent like 1 week, I buckled down and I wrote WebRPC. I remember it was like an intense week, and I was waking up. It was so funny. I was so excited about it because I wanted it for so long, and it was like working out. I was waking up every day at like 4 a.m. after, and I was coding on it like crazy. I couldn't sleep. And I was literally every day 4 a.m. starting and working all day long to code it all up, and I got it working. And it was so neat. And so, yeah, what you do is you define this schema, and you can either define the schema in a JSON structure. So you can define essentially your request and response payloads and your RPC handlers. So kind of like, it's almost like writing your like function declaration. Like you're defining, the method name and the arguments and its response type. And that's what you're doing there. And then we've defined it in a schema. You can either declare it as a JSON structure, or I actually came up with another thing called RIDDLE, which stands for RPC Interface Design Language. So I came up with my own little data structure that you could define the schema to kind of make it more succinct. And then what it would do, it essentially would take this schema, and then it had these interesting templates, and it would code generate either whatever client library you wanted. So in Go or in TypeScript or in JavaScript, and it created this kind of type safety between them. So yeah, it's pretty cool. And our engineering team didn't have to ever make any client libraries, So whenever, and it really changed the paradigm of how we were thinking about designing APIs now. There's so many things that were cut out. We didn't have to talk about REST and the different endpoints, and like there's a lot of we would just go to the schema, and the schema would be the source of truth on what's the interface to the API. How do I consume it? It's like it tells me right there. Almost like when you're designing like a data model, like a database schema. You design your database schema, and from there it's like the source of truth to your data models, right? And then you generate the client, and then at the client side, like the TypeScript world, you're dealing with the actual like objects. You're not dealing with like endpoints and HTTP requests. You're not even thinking about requests. You're dealing with like the native types. And then you just like call methods. And the result of it is that what was really neat is that now your like backend and your client, they kind of feel like they're like one program or something, because when you're in the client, you're just talking. It's like you're just like model.getUser or like users.findUser by name. And you pass the thing, and then you just say, and then you await that and be like, okay, well, here's your user object. And behind the scenes, it'll call the server and grab it for you. And if you ever change your server endpoint, because now you're going to add another endpoint called like find user by email, for something like this, then you just rerun like make proto, regenerates the client, you add it to your thing, and all of a sudden now you have your method. That's it. That's literally what you got to do. So it saved us a huge amount of time, and we've been using it for every single service out there. It's open source. We've been using it for a little while, and it changed again. It completely changed the paradigm, and it really has solved this kind of extra effort problem for us.
Yeah. One of the things I really liked about Rails when I started was coming from a bunch of Java or frameworks where every field and every database had to be written in like 7 XML files or something. Just having one source of truth for your schema and auto-generating everything else just makes your life so much easier because you don't have to think about keeping all these things manually in sync.
Exactly. Yeah, it's huge. The Java world, I think, has a lot of that stuff, a lot of those capabilities. But like when we're all like startup hackers, we want to use all the cool new toys, right?
What is your takeaway from having figured this out and solved it?
Yeah, I'm really pleased with the system. And the thing for me as like a startup founder, it's actually kind of crazy to think like when you're making a startup, like you're going to go and you're going to make like better software than teams of like big teams, like massive teams that are like really capable, experienced people. And yet people do it all the time, right? Like there's tons of startups. They're the ones always breaking ground and innovating. And it's like, in hindsight, it seems more crazy. But when you're there, it's kind of like, it's a different mindset. You're just kind of developing at the frontier, and you need to be fast, you need to be productive. You also have like all the possibilities in front of you. You have full autonomy. There's endless amount of creativity and lots to explore in the world of startups. There's so many vectors, but from the perspective of engineering, one of the neat things is you can be fast and productive. The meta game for me, the superpower of how to deliver great engineering, and it was really in the architecture. And the architecture was really about like system design and how patterns are formed to gain high quality interfaces and in simple kind of constructions that would amount to fewer bugs, higher performance, easier to maintain code, better team patterns and consistency. And so in my career, I always spent, even in my 20s, I was obsessed about architecture. I would read books around like software philosophy and design philosophy, design patterns. Like some of my favorite books are like The Mythical Man Month. Have you ever heard of that one?
Oh yeah, definitely. I was talking to someone the other day about how everyone remembers the part about how you can't throw more engineers at the problem, but no one remembers the part about how he proposes to structure engineering teams with like effectively one engineer and like 8 assistants.
That's right. There was a chapter about like throwing more engineers at the problem doesn't make the solution, like you don't solve the problem faster. Essentially, it can slow you down, which is interesting. Yeah. The book was written in 1975, and I highly recommend it to any single like engineering team. And actually, the other book is The Pragmatic Programmer, the Pragmatic series. I think that book kicked it off. What I'll say is like, actually for a long, long time, like everyone who worked with me, I would always buy them those 2 books. I would always, and like whether Christmas or I had literally had so many, I would always just give them away. I was just like, because they were so good, and I was like, I want to level up my team. You know what I mean?
Yeah.
So I'm like, which is great. So I wanted them to develop the mind of architecture, and there was a lot of intuitions that you develop. It's not just writing code for the sake of delivering code. It's about how the system is composed, to take a step back and be thoughtful about, how these things are connected and what's the responsibility of their domain. And it should be very logical and very simple, right? And when it is, and even name, I'm so big on like naming things properly, because if you can name things properly, people can more easily infer and understand just by like looking at the code on how things work. And as a result, again, teams way more productive, fewer bugs, higher performance. In an engineering team, obviously we all want to hire the best people in the world, obviously, right? That's not easy to do, right? Like if you're lucky, you might get like 40% of your team being like, world class, but you're gonna have to hire juniors. And in fact, juniors are actually really helpful too, because juniors can be fast or savvy. There's this beginner's mind mentality that you get. And like, that's the beauty of the startup. But one of the things to be able to unleash their capabilities is having a good, well-architected system. Because if you have a well-architected system that's, again, clean and so forth, that people can clearly see the conventions are very clear and they can follow these conventions, then they can be incredibly productive. All the time through my career, over the last 15 years, easily in the last couple startups, it's like, I'll hire someone, and once I lay out the foundation, I'm very confident they're going to produce the same code I'm going to produce, And then we get this compounding and great, and again, and tools help you with that. Good libraries and good tools and good frameworks, all of these things help us with the construction of these things, but also good architecture. So, the Mythical Man Month talked about this idea of the second system effect.
Yeah.
That was what they said, was that you ever like write a piece of software and then you're like, oh, I can make it better. You know what I mean? Mm-hmm. I can make the next one better. And then you go and you do the second version and then you like way over engineer it. You know what I mean? You
absolutely.
You like over anticipate, like, oh, my software in the future is gonna have to do this and that.
And you're fighting the last battle too. Like oftentimes, software's moved ahead, and you are not anticipating some of the problems you thought weren't solved before are now solved.
Yeah, exactly. And then you over engineer, you over design, and so now like I'm really careful with my team, saying like when people give me designs, I'm like, no, be explicit. Right now, what do we need right now? Just have clean design for right now. Don't over anticipate, because you'll end up putting yourself into oftentimes you're over anticipating.
It's kind of interesting because there's this parallel with web RPC that goes through a lot of things you've done, in that it's about modularity and reuse and byproducts, because you built this one standalone open and it stands on its own as a valuable piece of open source software, but you build it specifically to accomplish a task. And that's pretty common. And I guess even perhaps the story of Skyweaver and Sequence, where you knew you wanted a platform for Web3 games. And a lot of the path there was building a great game and abstracting out major important pieces.
Dude, yeah, you nailed it. I mean, it's like when we were making Skyweaver, like immediately we were working on Sequence the whole time. I mean, back then it was called Arcadium. We were thinking, and we decided to call rebrand to Sequence at some point. But the whole idea was like, I was like, you know what? I can like make this software, and while we're exploring this space, we can open source as much as we can. You know, we can take out an open source, and that's always what I've done in my career. Anytime I can open source, I'd like to open source. It makes me happy, to be honest. It also makes me kind of like, I don't know. It forces me to have like, there's a bit of a frame around architecture, because now I know that this is an isolated piece. It simplifies my design, I guess, because now I have this like thing that acts independent of all this other of my whole domain. You know, so it actually makes my actual application smaller as a result. That's why I like to do that. And so I have tons and tons and tons of open source libraries, actually. And I open source stuff all the time. And so Sequence for me was like on that very same path. And again, that's why and we're actually, just to say, we're actually going to open source a whole lot more of Sequence. And we're excited about like a lot of the next roadmap and exploring a lot of some of the infrastructure to even make it more peer-to-peer based, like things like the indexer and the relayer and so forth. And we have some prototypes around that. So really excited to kind of keep deepening into the space. But again, our focus is, you know, as a startup, there's a lot of things, but we very much care like what we believe just as a thing around Sequence and Web3. Because, you know, some people who are listening might be like, oh, Web3 is really cool, blockchain is really cool. Some people might be like, oh, it's crappy and it sucks and there's nothing I can do with it or whatever. The thing is, that's the whole point. Like, there's not enough great content, right? But we're going to see lots of great content, and, you know, content is utility, and we're a platform that's going to help, you know, drive that. And there's lots of other great work that's happening too, and scalability is being solved by so many people. There's thousands and thousands of incredibly brilliant people working on this stuff that are very inspiring and are very collaborative, of the open source roots and of that mindset.
Yeah, that's awesome. Well, you covered it a bit there, but I was going to ask you, what else should we be looking forward to from Horizon?
Yeah, so we are just like, we like always be shipping. This is kind of what we're doing. You know, we're like just hardcore. Our roadmap and our teams and the amount of like things we have in our belt, like it's completely crazy. I remember in the past, it's like usually when you're making applications, like you make an app, you're like, okay, I got my API, I got my app, like I'm good. Like that's what I'm focused on. We have 8 to 10 different like big microservices, like very important piece of stack. We have SDKs on the back end, the front end, Unity, Unreal, mobile, and then we have like a dashboard builder. We have a wallet product, and we have a marketplace product. Smart contracts, we have to do audits of everything. Like we have a very sophisticated DevOps setup as well. And then you're also thinking about making sure things are decentralized and hyper secure. Again, you really have to take the mind of architecture. Otherwise, there's zero chance that you're going to even be productive. Like how do you even maintain how do you even wield a system like this, you know, while still, and yet we're constantly shipping and pushing. So very, very pleased with what's going on. I mean, for us, this year is focused on our customers and our partners to help them, just in equipping them with amazing tech so that they can be productive. One of the things we want to do is we want to open source more of Sequence. And even though Sequence, the Sequence like we have also like a wallet product, which is a smart contract wallet. Instead of a wallet being one key, a wallet can be now consist of, you know, a dynamic set of keys with different kind of weightings and stuff like this. And so you can deliver essentially better user experience and have extra mechanisms around security. You can do transactions without having any tokens in your wallet. You can do automatic gas pricing, and that's all stuff that we have, and it's in market for a long time now. And a lot of the core is all open source. So like Sequence.js, the wallet contracts, a lot of our underlying libraries, Go Sequence, ETHKit. We really believe in this notion of, like, again, Web3 should be open and people should be able to kind of plug it in. So we are going to take our different services. And what I would love to do is turn them into peer-to-peer networks, like the indexer and the relayer. I've wanted to do it actually for 2 years, and I think we have a path to it. It's hard to doing all the things in balance, and we may do that. But there's a lot of, I can go into like the crazy depths of the plans for the index and the relayer, but it's a little bit too much TMI. Not that don't want to reveal it, but it's just going to be talking for 10 minutes. We want to open source as much as we can, or pretty much everything, while building a sustainable business. And we actually have a really good path to that. And one thing I'll say about that is, I'm not joking when I say I'm really passionate about open source. You know what I mean? Like, and I've been studying and observing open businesses that take the open source approach for a very long time. You know, we very much care about the general utilization of these systems, and we believe smart contract wallets are one of the key primitives that are going to help do that. Now, one of the things that, you know, in the community, it was last year that everyone started talking about smart contract wallets. They got really popular, and around account abstraction. It was like the term AA, account abstraction, and there's a few really popular standards like ERC 4337 and really interesting around these things, and got, again, which was great. But of course, we predated the ERC 4337. We actually looked at it. We're like, oh, should we upgrade it to it? Blah, blah, blah.
Yeah.
And there's a lot of things that we have a different idea. So we are going to be going down the path of producing our own standard and proposing it and so forth. So again, back to like, there's always a balance of business, research, and yes, that's some of the things that we're thinking about.
It's always been a high output enterprise, so I'm not surprised to hear of all the things on the roadmap. Seeing the tools you give people and then seeing what people are going to build with them are really motivating, and it's been a lot of fun to watch. We've been talking a lot about it over the years, and I note that a lot of the things you've predicted to come true have come true. So it's always a privilege to pick your brain. Thanks a lot for the time, Peter.
Thank you, Brett. And I just want to say also, like, we've been working together for like, I don't know, 5 years, I think. And I just want to say, like, you've been a phenomenal partner. You've been right there, consistent, always supporting us. So any startup would be insanely lucky to have you as a partner. Yeah.
Thank you for the kind words. That's it for this episode with Peter Kieltyka, co-founder and CEO of Horizon Blockchain Games. On the next episode of HiBit, we sit down with Gotham Bose, founder and CTO of Automat, to talk about how his company is using unattended robots to fully automate tasks that were previously done by humans. HiBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heinz. And I'm Brett Gibson. Thanks for listening.